So we were supposed to fill out, for those of you that got with us late here, we are supposed to fill out these two tables either by plugging x into the functions or putting these into y equals and looking at your table on your calculator. So what did you get for the y value of -1 on f of x? Julia? What did you get for this value right here? Ah. What did you get? It's not here.
-3.
Cheyenne. What did you get here?
-3.
All right. Oh, what did you get on this first one right here?
-3 Roman.
Roman? Thank you. What did you get for 0, Julia? What did you get for 1, Lindy?
Bro, is my stick not in there?
It should be. Avery, what'd you get for 2? What did you get for -3 on g of x, Jose?
Huh?
What did you get for -3 on g of x?
-2.5 was that?
No, no, no. No, no, no. That's not right.
Wait, the inverse? Two, I got 2.
2. No, that's not right either. -1. What did you get for -1 on g of x, Vinny?
Oh, wait, 0.
What did you get for 1 for g of x, Max?
I didn't do this one.
0. So easy.
1. Grayson, what'd you get for the last one?
I did this one wrong. 2.
Wrong, no, 2.
2. Does anyone notice?
A chance to answer the question, guys.
Well, he did. He said he didn't do it yet.
I didn't say that.
And Colby, he was about to figure it out and become a mathematician.
All right,
but
listen.
Lindsay's like, boom.
I didn't say
What do you notice
Yes, you did.
about these values?
This is cool. Everything that you say was going against you.
okay.
All that we did here was flip the x and y value, and we got our new table. This is what being an inverse entails. Anytime, anytime you have inverse functions, all that you have to do is switch the x and y, and you'll have the other points on the inverse function. So let's go ahead and graph these to see what this will look like on the graph. Everybody go ahead and graph these 2 lines, both of them. If you have multiple colors, I would use multiple colors to graph. All right, after graphing these 2 functions, what do you notice about this graph? Take a look. They intersect, okay. What else?
This one's so good. I'm gonna listen.
Do you notice anything else?
Commercial by Lil Baby.
Anybody at all?
No.
Do you notice anything about these 2 graphs?
There's a solution.
There is a solution. They do intersect. What else? They are reflections of each other. They are reflections because they are inverses. They are reflections over the line y equals x. That means that if I folded this graph along this line that goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, the line y equals x, if I were to fold this graph along that line, everything would line up. The pink line would directly line up with the yellow line. They would lie on top of each other if I folded along that line. Yes. Yes. Can you imagine it folded? You can't imagine it folded on top. And you wouldn't see that the yellow line would lie on top of the pink line?
Yeah, I see that it told me, but I do not see it.
It would be. I'm telling you it would be, okay? They would lie directly on top of each other. This is what a reflection is. Inverses are always reflections over the line y equals x.
No, it wouldn't. Because
So if you're graphing a function and it's inverse and they do not reflect over this line, you know you did something wrong. Something is wrong. So this is how you find inverses graphically. You look to see, are the x and y's flipped? And you look to see if it's reflected over the line y equals x. So over here I would say inverses are always reflected over the line y equals x.
No, it doesn't. That's not how it works. It's the same thing. No.
So just now we went over what inverses. So just now we went over what inverses look like graphically. Now we are going to solve or find inverses algebraically. Now it works the same way. Anytime it says find the inverse of a function, you should immediately think inverse means switch x and y. You're switching x and y. That's how you find inverses. You switch x and y graphically, and you also do the exact same thing algebraically. Now the numbering for these steps kind of got screwed up. As you can see, the step 1 is supposed to be change f of x to y. That was supposed to go up there. So step 2 is actually switch x and y. That's your second step. Step 3 is solve for y, and then step 4 is to change y back to f negative 1 of x. This is read as the inverse of f of x. Number 4. Anytime you see a negative 1 in function notation, that means the inverse of that function.
then where do we put the f of x to y? It's funny that.
It's supposed to go with the change. It's supposed to be change f of x to y.
Okay.
That's your step 1. Change f of x to y. All right. So first example, what does step 1 tell me to do? Step 1 is to change f of x to y. So f of x is turned into y. Then, what does step 2 say to do?
Switch the x and y.
Exactly. We must switch x and y. That means literally, instead of writing y out front, we are going to write x. And instead of writing y with the negative 2, instead of writing x with the negative 2, we're going to put a y. So I switched x and y. Now what does step 3 say to do? Yeah, step 3 is solve for y. That means get y all by itself. So what do I have to do first to get y by itself? What do I have to do? Minus 5. Grayson, what do I have to do? Grayson, what do I have to do?
I'm trying to get food.
I have to subtract 5 over. Then what do I have to do? Yes, divide by negative 2. What does my last step say to do? My last step, what did you say, Jose?
Change y to f of x.
Yes, to the inverse notation, meaning it's f negative 1 of x. You read that as the inverse of f of x
I tried.
is equal to, no, I said it was wrong.
He said it was right.
No, I said you need to change this, you need to change this.
It's wrong, man.
And that's our answer. I have just found the inverse function of f of x. So let me do another one. What does step 1 say to do? Well, no. What do we first do? Change f of x to y. Then what do we do? Yes, you're flipping where the x is and you're flipping where the y is. Did you both like just drink shots of espresso before coming back to the class?
I actually did.
Okay, you need to like. All right. Now what do we have to do? Subtract 4 over.
Oh, I don't have school Friday either.
Then what? Can I, right now, square root both sides?
Yeah, sure.
Is the parentheses that are squared all by themselves yet? No, so what do I have to do? Divide both sides by 2. We're trying to find the inverse, Grayson.
Yes.
So now, how do you undo a square? The opposite operation to squaring is square rooting. So we square root both sides. The square and the square root cancel, leaving you with what on that right-hand side?
Just to let you know, we don't have that much room.
I know. I'm lucky that I can zoom in and write. I'm so sorry. Then what do I have to do?
Shut up, Roman.
Add 5 to both sides. So I have the square root of x minus 4 over 2 plus 5 is equal to y. And what is my last step? I know, I'm sorry.
Why? Miss Ellen, I didn't want to forget all this when I come back. Are we gonna like review?
We have a quiz next class.
I'm not forget this by like 10 minutes after the class.
Listen, I'm going to do one more example.
You already forgot it.
So all we did here was switch x and y. Then we solved for y and changed y out for f negative 1 of x, or the inverse of f of x. All right. What does step 1 say we do? Change f of x to y. Now, this step can kind of be clumped in with switching x and y at the same time. So we know x comes out front. It might have been.
No, you don't.
And y is now on the inside of our radical. What do I have to do first?
Solve for y. -2.
Yes, I have to, not -2, add 2. Good. I add 2 to both sides. Then what do I have to do?
Divide.
Yes, I divide by?
Right?
Oh no.
What?
Can you put x plus
How do you get rid of 1/2?
What about 4?
You do times 2. If it's 1/3,
On this, what about
1/3, you would do times 3.
No, because the x doesn't have a 2.
But it's simplified.
What you could do is leave the x divided by 4. So you could write this like this.
Where else have you gone? Like,
But I prefer for it to be written like this. It doesn't matter in this case. Okay, so can I add 5 over at this point?
No.
No, it's still being cube rooted.
Yes.
How do you get rid of the cube root?
Square root.
Cube root.
What's opposite of cube rooting? Cubing.
Cubing.
You cube both sides. So the cube and the cube root cancel. You have to try it, I think.
but you just, all you did was move the, there's still a cube. All you did was move it. What does that change?
We're trying to get y by itself, Grayson. Because how are equations written? They're written as y equals. So we're trying to get y by itself here.
No.
Then what do I have to do?
+5.
I still have to add 5 over. And then what do I have to change y out for?
What's
Good. Inverse of f of x.
What's the difference from the cube for the 3 on the right and the 3 on the left?
I just asked that.
The cube, you mean?
Yeah.
We're trying to get y all by itself. Way up here, y is being cube rooted. To get something uncube rooted, you cube both sides. So the whole objective here is to get y by itself because that's how functions are written, as y equals or f of x equals. So we switch x and y, and then we solve for y. And that's how we get the inverse function. Any other questions?
Will that ever be like a 4? Like
Yeah, it could be.
so if it's a 4, you just put the 4 in there.
If it's a 4th root, what do you do to undo a 4th root? If it's like this, what do you do to get rid of the 4th root? Not cube. Raise it to the 4th power.
That's not cube. Oh, that's 3.
Cube is 3. All right, you guys are doing these 4 problems over here. All right, guys.
Wait, I'm not done.
If you'd like to check your answers, this is what I got on each one of these. Number 1, you should have gotten f. The inverse of f of x is x plus 6 over 3. Number 2, you should have gotten the inverse of, this is actually g of x.
You told me it was, whatever.
What?
You told me that -1 was after the x.
No, you asked if it was after the f. And I said, yes, it's after the f.
Where I said f.
You said f.
Oh, my bad.
So g, the inverse of g of x is the square root of x over 2. And then after the square root comes a -3. Number 3, the answer should have been,
Whoa, what?
did I go too fast?
No, three.
Oh, 3. 3, the inverse of f of x is the cube root of 2 times x plus 5. And then after the cube root is -9. If I'm trying to get rid of a fraction, all you have to do is multiply by the denominator. So if I'm trying to get rid of 1/2, you just multiply both sides by 2.
Are we gonna go over this before the quiz? Where'd you get the x plus 5?
You had a 1 in this class.
Oh, that's a 3.
That's her fault.
Uh-oh.
Not me.
Did I copy it down? See, look, I was sloppy and I screwed up.
Look at you.
Look at me. This is why it pays to be nice and neat.
Let me teach the class.
Let Roman teach the class, yeah.
No, let me teach it.
Chuck over.
I taught Roman how to do it, and he had a 1 in this class, so.
Roman actually has been stepping up lately.
Do you think he could pass the year?
He passed the test,
Yeah, by 70. I barely
Another
passed
year.
but you still passed it. Whereas before you were getting zeros, so I call that improvement. All right,
You were getting zeros on the test.
he just wouldn't do them. All right, then number 4, I will go back up. The inverse of h of x is x minus 5 over 2 squared plus 6. Are there any questions on any of these?